Today, we are going to be configuring drive SDO files in XGPM, then writing those files to the drive via the XGB PLC, and finally reading the files back to verify the changes we have made. Once we have our EtherCAT network physically connected and our drive nodes identified and assigned to axes, we are ready to configure the parameters for those axes, as well as the servos themselves. The axis parameters are contained in the XGPM software, and if we were to remap which axis went with which drive, those parameters would stay with the axis number. The servo parameters are actually stored in an SDO file that gets written directly to the drive. If we were to remap which axis went with which drive, the servo parameters would follow the drive node number, not the axis number. Let's start by looking at the axis parameters. We go to the project window on the left side of the screen and maximize the number 1 axis data heading. We can then double-click on Parameter. This will open the new one.parameter window. This window displays all 8 axes in the PN08B, so we could go to the parameter for any of the 8 axes and still get to this same window. Let's maximize the window and take a closer look at these parameters. The axes will track their position using pulses or engineering units. The step and direction axes work the same way. Even though EtherCAT motion control doesn't use actual electrical pulses the way step and direction does, the software uses the same base convention for ease of use. We won't go through every single parameter as there are a lot of them, and the manual and help files already do this. We do see that the EtherCAT axes do have some extra parameters that are not present in our step and direction axes. Most of them have to do with drive controls that aren't available to step and direction outputs, such as encoder type, torque command, and the like. Again, any changes to these parameters will follow the axis number, not the drive node number. They also will be written to the motion controller during a normal write to the CPU. The drive SDO parameters will require a SDO write for them to be written. Now let's look at the drive-specific parameters in the SDO file. To access these, we won't go to the axis number, but rather to the drive list above it. Let's look at the parameters for drive slave 1, which in our case is node number 1, and is our x-axis. We can double-click on SDO parameters to open the parameters for this specific drive. This opens the new one.slave1.SDO parameter window. In this window, we see a long list of different drive parameters. We see the index in the drive for each parameter, the name of the parameter, the unit if applicable, as well as the current value, the initial or default value, and finally if the parameter is read-only or read-write capable. Let's take a look at how to alter these values. Most of these parameters are either automatically set or are correct at the default, so we don't want to alter them. Changing many of the other parameters would require a lot of planning and engineering, so we will avoid those as well. Let's keep it simple and look at the parameter for when the drive will enter a warning mode for overload. Changing this won't really influence the system very much, and it doesn't really require a lot of planning or engineering. If we scroll down slightly, we find this parameter is at index 2010:00. Its default and current values are both set to 50%, and it is able to be read and written. Let's change this value to 75% instead. To do this, we simply double-click anywhere in the row. This will open the Set Current Value pop-up window for this parameter. We can change the 50 to a 75 and click OK. We have now changed the parameter in the software, but it isn't on the drive yet. Remember that a normal write to the CPU includes axis parameters, but it does not include SDO parameters. For this function, we have to perform an SDO servo parameter write. We will find this option under Online EtherCAT Slave. In our case, it is currently grayed out. That is because we haven't connected the EtherCAT network, so we aren't communicating with any of the slaves yet. We first must select Connect to All Slave and wait for the software to run through the connection process. Once it gives us the confirmation it connected successfully, we can now go back and access the SDO servo parameter write function. This will open the SDO servo parameter write pop-up window, and here we can select which drives we will write to. We could write to just the drive we altered, which would be the slave 1 drive. However, I find it's easier to not accidentally miss parameter changes if I just go ahead and write to all the drives each time I do this step. So let's select the checkbox for the PN08B motion controller to select all 3 slave drives, and then click OK. The software runs through the process of connecting to each drive and writing the SDO files to it. It ends by giving us confirmation that the write occurred successfully. If we go back and disconnect the EtherCAT network, and then run an AutoConnect to pull the SDO files from the drive, we can verify that our write happened successfully. We can open the slave1 SDO file once the AutoConnect completes, and we see that our overload warning level shows 75 rather than the default of 50. Perfect! We have successfully written access parameters and drive SDO parameters using the XGPM software.